Kia ora, and welcome to this video about computational thinking. The first point I'd like to make is that computational thinking isn't just about coding. It's an actual way of thinking. As you'll see, all of the key competencies are supported by computational thinking. This is especially true when students are working with others to create projects or when they share what they've made with others. So here's a definition of computational thinking. So it's looking at taking complex problems, understanding what the problem is, and then developing some possible solutions for that problem. Once we have that solution, we can present that in ways that a computer or a human or both can understand. There are 4 key techniques of computational thinking, and as I talk about them, you'll probably notice some similarities to other problem-solving methods, especially those that you might be using in maths. So it starts off with decomposition, which means that you're taking that big problem and you're breaking it down into smaller, more manageable parts. Then we have pattern recognition, where you're looking for similarities, you're looking for patterns, you're looking for similarities among different problems and within the problem. Abstraction means focusing just on the important information and ignoring anything that's irrelevant. You'll have done this in maths problems where you looked at what are the key points that we actually need to focus on in order to solve this. Algorithms are step-by-step solutions to the problem, or the rules that we follow to solve a problem. So the steps are performed in a particular order, and we can have algorithms in everyday life, for instance, getting ready for school. And the ordering of each individual step might not matter, but overall order will matter in an algorithm. So if I'm getting ready to go to work, for instance, I could have my breakfast first, or I could pack my things for work, but I need to do both of those things before I leave for work. So algorithms can be written in a machine-readable form, a form of code, or they can be written in a form that humans read, which is called pseudocode. So the example on the left there would be pseudocode. It can also take a pictorial form, or you could just use arrows, for instance. You can use diagrams, all sorts of things like that, anything that a human can understand. And on the right, an example of a form of machine code, and things like using different kinds of block coding or JavaScript or Python code are all sorts of examples of different codes. So thinking about algorithms, have a look at this list and think about which ones are algorithms and which ones aren't. You might like to pause the video for a minute so that you can have a look and have a think before I give you the answer. So you could pause it now. Okay, so kit set furniture instructions, of course, a very good example of an algorithm, very step-by-step and order matters. Dictionary is a confusing one. A lot of people get confused because you're actually using an algorithm when you use a dictionary. So you're using your knowledge of alphabetical order, and you might, if you know that the word starts with M, you'd know that it was near the middle of the book. If you were using it a letter like B, you'd know it was near the beginning and so forth. But the dictionary itself isn't an algorithm. The dictionary is just a list of words in a particular order. Safety guidelines can vary. Some safety guidelines are step-by-step instructions, and others are just sort of general information. Knitting patterns, another really good example of an algorithm, as are recipes. Phone books are like dictionaries, and they are not algorithms, but you use one in order to find information in them. Although, of course, both dictionaries and phone books are available online now, and you wouldn't have to do that at all. You just type in the word or the person you're looking for. Novels. Most novels are not algorithms. Most of them are just a story. They're not a set of instructions. The Hoki Toki song or Mahunga Pakahiwi, any songs like that are actually a type of algorithm because they're giving you instructions. Put your left foot in, put your left foot out, etc. Although you could argue that maybe order doesn't really matter, but if you're going to get the song right, then it does. So if we're thinking about why we would use computational thinking, here are a lot of really good reasons why we would use it. So it can develop our literacy skills. There is a ton of problem solving when we are using computational thinking. And definitely, it is definitely one of the thinking skills. Perseverance. It can be really enlightening to watch your students working using computational thinking and which ones will persevere and which ones give up really easily and want you just to tell them the answer. They're not prepared to try and fix their problems. Definitely innovation, because when you are using computational thinking, you are creating and you're creating solutions to problems. Ton of creativity happening when you're doing computational thinking. There'll be numeracy skills, and you have to have flexibility and lots and lots of those skills, developing confidence in yourself, all things that are going to be developed by computational thinking. You don't need to use a computer to work on computational thinking. There are lots of ways that you can develop this skill through what are known as unplugged activities. So, for example, guiding a robot through a maze. Now, this doesn't actually involve a robot. You have two children. One of them is the robot and the other is the programmer, and they give the instructions. You can also use alphabet grids for children to give instructions on how to spell a name. You can use lots of maps. Any of the position and movement activities in maths will be helping to develop computational thinking, as will most of the procedural writing activities that you do, because they are instructions and, of course, are algorithms. So one of the things that's important with this is to use the vocab, so use words like algorithm. So say we're developing a set of step-by-step instructions. Another name for that is an algorithm. When they make mistakes and have to fix them up, then we talk about how we are debugging. So this page on the IPL site has got lots of unplugged activities and ideas, and I'll put the link down below the video for you. The next thing you could look at is looking at free programs like Scratch, which use coding. And so you can sign up to Scratch. There's a junior version which works on iPads, and there's an app for Chromebooks, and it is free to use, as is the full Scratch version, which is in a browser. And in the newer iPads, it will work in a browser on the newer iPads, which is great. So sign up for an account first, and then click on Create. And that will give you access to a whole lot of coding blocks. And you start off with a little creature known as a sprite. You can delete him and get another character. So you click on the bin, click on the cat, and there are lots and lots of different characters to choose from. So let's have a dragon. And you can have lots of backgrounds. So down here it says stage. If you click on that, on the little picture, you can go and choose the background that you want to have for it. Let's have a dragon in space. There is options where you can draw your own backgrounds and sprites as well. So here we have our dragon. I'm actually going to decrease the size of the dragon here because it's a little hard to see him moving when he is so big. So we have him here. Now, the first set of blocks there are movement blocks. So we might get him, for instance, to move, let's go 100 steps. There we go. And again, I can move him back. We start off with what's called a hat block. So this one is when the flag is clicked. So when the green flag is clicked, he'll do whatever the code says underneath. I could also have used one, for instance, that says when the sprite is clicked. So when I click the dragon, he moves. Let's take that off and put this one back on. So you can see how this is computational thinking because we are giving step-by-step instructions to the sprite. We want it to walk 100 steps. I can use looks block and get it to say something. Now, if I do that, it will put a speech bubble for whatever it is that I want it to say. So, kia ora, and click the flag, and there we go. So coding sites like Scratch allow us to use computational thinking, but let's remember the definition of computational thinking, which is taking those complex problems, understanding the problem, and developing solutions. So the process of computational thinking doesn't need to involve sites like Scratch or other coding sites, but it certainly can. The key techniques of computational thinking are the ones that we need to be keeping in mind: the decomposition, pattern recognition, abstraction, and algorithms. I hope that's helped to give you a better understanding of computational thinking. If you want to know more, I'll put the link down below the video, which will give you the site, which has a lot more information for you.